the needs will be much more mixed, and there may well be quite a bit of model building. Okay, so ladies and gentlemen, the first thing I'd like to turn to is this issue of hybrid modeling, and after that we'll be going into a discussion of some of the very exciting prospects for combination of dynamic modeling with big data. Okay, so I'd like to talk about hybrid dynamic modeling and the patterns from it. So the opening reflection here is the fact that system science methods and dynamic modeling methods in particular, agent-based modeling, system dynamics, and discrete event modeling, have traditionally come out of quite different disciplines, and people have tended to focus on them as competing alternatives for modeling. As a practitioner of all three, I can tell you with not just confidence but authority that no one system science method offers a fully adequate replacement for the others. And there's great synergies that can be secured by combining them in a single model. Now, we've seen some elements of it, and so I'm going to hit less on the motivations for that, but I do want to highlight a set of motivations for doing this. One is the fact that in some of these methods, it's just a lot easier to represent certain types of phenomena than in others. So if you're going to represent resource-constrained processing along workflows, discrete event modeling has no peer. It has no rival in terms of the ease of expressing this. If you're going to be representing networks and agent interaction and in a spatial context, agent-based modeling, has exquisite abilities. So comparative advantages is one of the sort of delineating factors between these, and one of the motivations we use hybrid modeling. A second reason we use hybrid modeling is because of the capacity to undertake different analysis with different sorts of models. So in this case, there's certain types of analysis that we can perform with one type of modeling versus another. System dynamics, for example, provides an extremely powerful way to analyze what's driving the system at a given time and to analyze long-term potential behavior of a model and possible routes of model behavior over a wide variety of possible parameter values without the need to exhaustively run the model. If you have certain types of analytic needs, certain of these frameworks may be easier to come across than others. An example would be if you want to perform analysis longitudinally. If you have a large set of administrative data and you want to compare results from the model with that administrative data at a longitudinal basis, you need an individual-based model. There's just no question about it. You're not going to, with an aggregate model, such as an aggregate system dynamics model, get the individual trajectories you will need to match against that data for face validity. You will not be able to calibrate to that longitudinal data. You won't be able to take that longitudinal data and use it to perform cross-validation with the model. That just won't be possible. A third component, though, that I wanted to emphasize, and it's one of the most important, is with a hybrid model, I mentioned this earlier, but I'll emphasize it again, you have the capacity to evolve the boundary as you learn from the modeling which areas of the model need expansion, which areas need enrichment. As you learn from working with the model what it's sensitive to, what things are really helpful for explaining phenomena, that may shape your desire to enrich certain areas of the model. And it's this ability to shift the boundaries, what's captured in a discrete event context, what's captured in a system dynamics way, in an aggregate fashion, what in an agent-based way. The ability to adjust those boundaries has great value. In the theory of real options in management science, they talk about the fact that options have value, flexibility has value. And it's the flexibility to evolve these boundaries between different areas of a model, that how you pursue them methodologically can be very valuable. Another thing that Jeff has run into quite a bit in his modeling, and I've certainly seen some in my own, is the fact that certain types of modeling resonate with certain types of stakeholders. Clinicians often conceive of the world in an individual-based context. They like to think about clinical encounters, episodes of care. And if you want a model that holds weight with clinicians, sometimes to have the requisite buy-in, you will want to use a representation that secures that confidence on that part. So you'll want to use a representation that is at a level of resolution that they can recognize. Jeff talks about GIS, for example, being a real selling point to certain types of stakeholders for models. That models where you might not think for your research frame, for your research question, it's absolutely required to have that GIS component. It's just that in terms of securing that buy-in, securing that sense of ownership, that sense of involvement by individuals, incorporating that GIS will just open eyes. It will open doors to you. That, in the real human theater of modeling, that is an important consideration. It's not merely a matter of sort of cognitive deliberation about what is needed. It's a matter of what will help make a useful model actually get used, as Jeff puts it. So in this case, stakeholder resonance is sometimes a motivation for weaving in some of additional types of modeling, weaving in some discrete event modeling to capture those clinical care encounters and the resource needs. Maybe there's one stakeholder in the team that really is interested in resource use, and if you can put it in easily, why not, if it will mean a successful model. Greater computational efficiency. It turns out that models differ greatly in terms of how long it takes to run them. An aggregate system dynamics model of a given sort of system and an agent-based model of the same system, although with more detail, might differ from each other in orders of magnitude in terms of speed. And if you are seeking a system where people will interactively run your model as part of group facilitated sessions, if you want stakeholders to be engaging with and talking about it, you need to consider the fact that certain types of modeling are more efficient, and having a component of your model captured perhaps at an aggregate level, a component that doesn't need all the detail, might buy you 5 times the level of speed. It'll go 5 times faster, which could be of considerable interest. And finally, there's this phenomenon of multi-scale modeling. Sometimes we wish one type of depiction for detailed processes, maybe physiologic associated with weight change, and another type of representation for GIS level phenomena, yet another type for policy level phenomena. So these, from my work, are 5 hybrid modeling patterns that I find extremely compelling. Several of them, I've actually already shown to you. One of them we built up, service population interaction. People present for care at a service, and they flow through a process because of that, and they are treated. The case that we looked at was with an infectious disease. In the case of communicable illness, where people came in for treatment, perhaps antibiotic treatment. But as a general phenomenon, whether you're dealing with chronic diseases or communicable diseases, for those diseases where the care component and the exchanges that take place in the care component between informal caregivers and formal caregivers, between informal caregivers in the family, say, and physicians, can be very important for management of chronic diseases, for transmission of information across that interface. And so service and population interaction can be of great interest when it comes to chronic diseases, for example, in their management. But a second component that we will be looking at, and we could build if there were interest, it would take about an hour, maybe 45 minutes, would be we have an aggregate model coupled with an individual-based model. People flow from the aggregate model down to the individual-based model. They become agents once they reach a certain level in their risk. they become high risk or at risk, or when they enter a particular region of the system where we really need a more detailed view. So you have kind of a zoomed in view for part of the model that is at an individual level and the rest is at an aggregate level.
Sorry, Nick,
yes.
So I understand that. Is that
Yeah.
basically, you have the overall population, you have a certain incidence rate, and then once a person becomes incident with an illness, then they can flow into the individual.
Yes, with the proviso that it doesn't have to be the whole population with an incidence rate. It could be stratified by 5-year age categories, 2 ethnicity categories, and 2 sexes. So, but it's an aggregate view of a population or subpopulations thereof, and each of them is subject to an incidence rate. And when they become incident, once they become an incident case, they are turned into an agent.
So that kind of addresses one of the things we discussed yesterday was, rather than get bogged down trying to simulate an overly large population.
Right.
You might have that at the aggregate level.
Precisely.
You only are really focusing individually on the smaller subsets.
That's right. So you focus your model on individuals who are pre-diabetic. Your agent-based model has pre-diabetic and diabetic individuals, and the remainder of the population, 80% of the population is captured with an aggregate model. And maybe it's not captured totally aggregate. Again, it's broken down into some risk categories, etc. But you don't have the social networks. You don't have the representation of people's home in a GIS context. You don't have all their history until they reach that point in the risk continuum. Yeah. And we're going to see each of these in more detail in just a minute. So agents driving aggregate system dynamics and aggregate system dynamics driving agent evolution as well. So we're going to take a look at this. Now this one, the hybrid ABM-Discrete event modeling, we've seen it in our context. What we didn't do is have a physical layout. It's really easy to do. That'll take about an hour to do. A little bit less than an hour. We could probably, again, do it between half hour and 45 minutes. If we want to take that model we had built up earlier and add a visual representation to it, probably half an hour, maybe 45 minutes. Why would you have a visual representation? You'd endogenize travel times within the clinic, so you could reason about placement of resources. You could reason about the time taken getting from A to B. You can reason about aspects of the physical layout. But equally important, you could show it to someone. And they could say, I recognize that. That's my clinic. Wow, you've got my clinic in there. And that might lend buy-in, where otherwise it was absent. So, here we have this population, and they go present for care in this sort of model. And you've seen that sort of thing, right? But we could show it visually. Okay, I'd like to talk about this one, and this is one we could also easily build up. And again, it'll be around 45 minutes to do, and I'd be happy to do that either this morning or this afternoon. And here we have an at-risk population that is captured within an aggregate population. Oh, great. And I'd like to open a model for this one while this spins. Okay, so ladies and gentlemen, if you go to the list of possible models, there will be a set of, so this is not model built in class, but rather example models under participant resources. Any logic 7 examples. There is a model in the hybrid models area. So I draw your attention to this hybrid models area. It's a subfolder. Do you see that? Hybrid models. And I'd like to go down to the hybrid model area. Okay? Do you see that? So it's under any logic 7 examples. And then if you go down, there's a hybrid model area. Do you see that? I'm getting, okay, you do see that? Okay, hybrid models. And then there's one called the budding hybrid SD-ABM model. Okay, I'd like you to go download that and let's open it up. Okay, so budding hybrid SD-ABM model. Okay, so it's downloading it, and I'm going to go open it up in AnyLogic. So having downloaded, we'll go open this model, and I will open it in the same way so I see what you see. Here's the budding hybrid. So what this model will depict, ladies and gentlemen, is something like this. And it's just what was being asked about by Matthew. So here we might see some general population, perhaps 90% of the population, 80%, most of the population often. They become at risk, perhaps, and then at some point they become fully individuated in the sense that they become an agent, a full agent. And I'd like to run this model so we can see it here. So maybe before, well, here, okay. So I'll go run this, and then we'll try to make sense of the cacophony. So here's a stock of non-diabetics. They become diagnosed with diabetes, and when they become diagnosed, they then become an agent. You could see agents being added in here. Do you see that? These circles. You could see this agent-based population of diabetics is growing over time as they are flowing out of this stock and into the state of agents. And we can go down and look at a particular agent, and well, an agent representation is particularly stylized there. But the point is that they are being individuated when flowing out of this stock. Now, why would you do that? Why would you do that? Well, it allows for a tighter focus for your agent-based modeling assumptions. You can focus in your individual-based lens, which is a very powerful but fairly involved lens in terms of theory and data. You'd focus it in on the population of greatest risk. You don't have to deal with the whole population for an agent-based description. It's lighter weight simulation. You're simulating most of the population in an aggregate model, which is amazingly economical computationally, amazingly frugal. And you can do, because of that, you can do faster experimentation, which can lead to speedier insight. You have a much smaller agent-based population than you would if you had to capture the whole population. And we have several models which have come out of our lab which make use of this. One of them is a model that's included also in your list called the Beifong-Rennes model, and there's also a model of ward-specific patient dynamics that came out of one of our incubators that also was notable for capturing this in a service delivery context. So here, these agents can be given networks, spatial context, individual history, individual situated decision-making based on their particular context, preferences, and can genuinely evolve with all the kind of richness that agenthood allows, continuous value of variables, but they don't have to exist through their entire life course as agents. This does have some trade-offs. There's a question of how we lend these people, for example, their location, if upstream all we keep track of is the Australian state from which they come. We have to lend them a particular location here. Maybe up here we keep track of their age in 5-year age categories. When they become individuated as agents, we give them a precise birth date drawn from some distribution with associated with that age as implied by that age category. We have to lend them a social network down here. But it does, so it's not without some complications, but it does provide a very convenient way sort of characterizing the population into a rough and ready model at an aggregate level and an individual-based model at a more detailed level. Yes?
And for situations where illness is resolved completely and cure, can you basically delete the individual agent?
Yes. Yeah. Yes, and in fact, in a model guided by Jeff, which came out of our incubator, not this past August, but the previous August, out of our agent-based boot camp and incubator, that's what happened. So they would become an agent. They would stay as agents for a certain amount of time, depending on their status, their health status, or their position within the system. and then they would flow back into an aggregate category, and their information at an individual level become much coarser for that aggregate category. I would note that you could save away their information to a database then, and so and have a certain chance that someone who comes back is one of the people that was there before, and you give them all those attributes they had earlier. So there's some potential they might even circulate sort of back amongst these, and actually it will be sticky. It will remember the particular agent with which they're associated. Probabilistically, you'd say, a certain fraction of these were seen before. They're frequent flyers, and we've seen them before. So you can capture that sort of back and forth to the aggregate. What you will not be able to do is capture their complete longitudinal trajectory in the aggregate fashion, because that is not compatible with an aggregate lens. An aggregate lens just doesn't lend that sort of complete understanding of the life course, which is so important for certain types of inquiry. Okay? Any other questions about this? It's a very economical form and very easy in any logic. Very easy indeed. Okay? Okay, let's talk about system dynamics-driven agent evolution. We've actually seen this, so I'm not going to spend that much time on it. But going back to 2007, it's been one of the features of our research program, and we have a more recent paper, particularly for communicable disease epidemiology and immunological dynamics, where there's actually quite a lot of richly laboratory-informed system dynamics and compartmental models that characterize evolution of a given individual. And we have within each individual stocks and flows, and then those individuals are linked up in networks and affect each other. Sometimes the stocks and flows within an individual are additionally supplemented by state charts. But you folks have already built a model like this. As recently as yesterday, you built this convenience store model, and here we had a representation of a person in terms of action charts and state charts alongside a system dynamics model. What you didn't realize is just how radical this is. This is a thing that, worldwide, there's only a small group of people that it's really at the cutting edge of what is possible, but AnyLogic has made it very straightforward at a mechanical level. Conceptually, it's an extremely rich strategy. One of the big emphases here, and I don't think there's an appreciation in many of my agent-based modeling colleagues, just how rich the literature is on regulatory processes as described by system dynamics. The literature system dynamics focuses on feedback and accumulation processes, and both as a more tightly defined tradition and in terms of the broader tradition of ordinary differential equation modeling, compartmental modeling, there is a huge amount of insight that can be tapped concerning sort of continuous regulatory processes. And these processes are often, I find, they're underrepresented, they're underconceptualized, they are often omitted within an agent-based context. Ladies and gentlemen, so much of what drives our evolution as individuals, as societies, and as institutions are regulatory processes. The processes like homeostasis that keeps each of our systems in balance, that resists perturbation, that resists disturbance. They stabilize our systems. And when it comes to something as diverse as infection or maintaining our salt balance in our body, when it comes to food-seeking behavior, when it comes to aspects of psychological functioning, there are very important regulatory processes. And the language of many scientists is rich in terms of these, referring to these processes. So we talk about co-regulation of a caregiver and an infant, or we talk about effective self-regulation for children being important for appropriate development, and shortcomings in self-regulation leading to adverse societal and individual outcomes. It turns out that there is a wonderful set of theory that's been developed using the equivalent of system dynamics models, or explicitly system dynamics models, that characterize these phenomena. Similarly, phenomena like that Jeff will has been trying to introduce into the health services area, such as the response of people in a service delivery context to work pressure, how that affects their patterns of work, and at an institutional and project level, regulatory processes are central for understanding behavior of a system. And in the agent-based context, there's rarely, I think, a recognition of the need to represent these processes. But from a system dynamics perspective, often if you don't represent the underlying feedbacks governing regulation, the feedbacks that drive an individual to sort of respond to their current state and try to aim at a target state, you are often missing the boat with certain types of phenomena. And within the context of system dynamics modeling, we can capture those regulatory factors very nicely, and often do so with reference to rich theory within the literature. So, whether it's coevolution of weight and weight norms, this is a very big area where you could apply this. So I have some perceived target weight that I develop based on my understanding of health consequences, but also based on the weight of people around me, and I shoot for that weight in my own behavior, and based on different social surrounds, my target weight might be different than someone else's. That's characterizing a regulatory process, and there is no tradition nearly as powerful or as insightful as system dynamics to characterize a phenomenon like that. And by incorporating a hybrid model, you can do that very nicely. Same thing with sort of the impact of phenomena on immune system dynamics and strength, immune memory, and the impact of exposures to pathogen. This whole phenomena of being in an overly sterile environment may cause our immune system to decay, or having treatment that comes too quickly may cause us to blunt the buildup of our immune response. We can represent that with very nice characterization within a system dynamics context. And also the coevolution of pathogen reservoirs in individual health. So when it comes to sort of these target processes, these targets associated with healthy behavior, healthy physical activity, weight, and so on, I think these regulatory processes have a big role to play, and they can be captured very nicely in a continuous form using system dynamics modeling. So system dynamics within agents. Yes, Jeff?
Just to throw in some food for thought, there's an interesting body of literature that talks about the regulation of perception as behavior as the regulation of perception, and of course politicians and spin doctors understand it. And there's a guy named William Powers who has developed this idea of perceptual control theory, really in terms of robotics and limb prostheses. And for people who are in mental health in particular, I think it's a very powerful concept that can be explored with exactly these mechanisms. Been looking at it, ways of really understanding learning. So the idea is reinforcement of beliefs. The idea is that seeing is believing, but believing is seeing. So that co-regulation of perception. In fact, Powers basically says all behaviour, what are we controlling? We're controlling perceptions. So we decide what we see and what we don't see, and what we choose not to act on in the environment when we see, and that drives all behaviour. And he's got some very interesting experimental observations that at least corroborate that.
So shaping what we see, what we don't see, and shaping our behavior to try to align what we see with sort of what we want to see.
Yeah. So and if anyone's interested in that, I can point them to the relevant thing. George Richardson's got a bit on William Powers in his History of Feedback Thought book. He sees him as interesting because he started off as a cybernetics guy and moved into servo mechanisms, and that kind of is the two bodies of system dynamics, but that's another story.
Yeah. Yeah, that's very interesting. Jeff has a set of materials on Insight Maker, which are very thoughtful in terms of their depiction of feedback-based processes and regulatory processes in the context of health in particular. And I'm sure he could point you to that, and maybe late this afternoon, as I do some wrap-ups, we can point people to your remarkable and very thoughtful sort of compendium that you've accumulated there, you've built up there. Just a couple examples for this system dynamics driven agent evolution. One of the areas where we've used this very, very well is when we have spatial phenomena that we want to capture, and each agent here is a patch of space. And we might want to capture, for example, the dynamics of mosquitoes. Now, it's come to my attention in the past few days here in Melbourne that Melbourne is not entirely devoid of insects. I particularly note flies as a local specialty of worthy of comment. I will assure you that our fair province in Canada is also not devoid of insect occurrence, and our local fauna in that area is of note is the mosquito. I don't think I've made the acquaintance of any local Australian mosquitoes, but if you were to come to our neck of the woods, you would enjoy the rapid acquaintance with a certain number of mosquitoes, and we have models which simulate West Nile virus risk for certain regions of our province. These are broad regions that might be kilometers by kilometers, and we can capture those the dynamics within these regions using different modeling methodologies to try to capture the mosquito populations during certain types of year with an agent-based modeling would be a fool's errand. They are sufficiently voluminous in numbers that trying to capture each mosquito as an agent would be taxing to even the most scalable platform. And as a result, what we do is we have patches that are individual agents in any logic. And within each patch, we use system dynamics modeling to capture the number of mosquitoes. Mosquito histories and particular longitudinal progressions are less of interest to us than counts. So we don't need to capture social networks or individual histories at the mosquito level. And so system dynamics works exquisitely well, and we have stocks and flows within agents. In other cases, we've added stocks and flows to certain regions. These might be regions within a facility, for example, particular surfaces, door handles for things like nosocomial infection, or for certain places within a geographically spread network to figure out how much pathogen is built up there. And there are dynamics of pathogen associated with the pathogen reservoir associated with each of these locations. And as people circulate between them, they shed pathogen or get infected by that pathogen. And one of the models that I've given to you does exactly this. Here's the spatial patterning with mosquitoes. My student Wan Yi An built this little model here, but we had a very empirically grounded model of mosquito and bird interactions and the infection on people. And we can very nicely capture spatial dynamics, easy visualization. And we also have a somewhat similar approach we've used for nosocomial infection within long-term care facilities, which gets into my next lecture. Another case which is also of note here is cases where you have individual agents that might represent, say, tobacco companies or food companies, or organizations, maybe individual organizations and service networks, and they affect the evolution of a population that's captured in a more aggregate level of people. So here we have perhaps our attention is on service network organization and driving of the health status of the population by tobacco company interactions and interactions between STEM and regulatory authorities, and we have a more stylized representation of the population at an aggregate level. Finally, there's cases where system dynamics drives the evolution of an agent-based population. System dynamics here captures the evolution of the environment, perhaps in terms of number of mosquitoes, perhaps in terms of the amount of pathogen built up, perhaps in terms of the regulatory environment, and that environment then impacts this agent-based population for people. So we have a dynamic model that is multi-level with a high-level characterization of certain environmental factors impacting particular individuals. And that pathogen reservoir can be seen as that in the sense that you have these reservoirs of pathogen impacting individual people. I should note that we have some models that are tripartite models. They simultaneously have a depiction of an agent population, discrete event modeling for service delivery, and system dynamics, perhaps for an upstream population or aspects of individual evolution that can be very, very useful. I think this list, if you look further, I'm going to drop it off at this point, tempus fugit, but if you look within these slides, you will find, ladies and gentlemen, references to example models, many of which I have provided to you as part of the collection of models here, and you will find for each of these examples cited that you may want to look at that are illustrative of these different approaches. Okay? So that was a little bit on hybrid modeling. It's something I've woven through this entire boot camp, and in that sense, perhaps it's less new to you. But if we consider the evolution of dynamic modeling over the next 10 years, I am convinced that this is going to have profound effects. We are seeing now the emergence of a much more inclusive and much less tribalistic system science landscape. In my generation, but especially generations before, system science was highly tribalistic. The people who taught system dynamics often knew very, very little about agent-based modeling and couldn't really comment on the trade-offs. Same thing for those agent-based models in system dynamics, same thing for those doing agent-based modeling and compared to discrete event and vice versa. And even now, I find in the older generation, it's quite common that I'll speak to someone and they have just no idea about the other techniques. Except to say that their technique is better. That's one very common thing, and it's unfortunate. It was very rare before the past few years, and I mean literally few years, for a given student to have training on more than one technique at a time. They were lucky to get training in any technique, and the idea of getting it in multiple techniques, there just wasn't that breadth of expertise. And there were totally different tool sets, right? You would use Repast for agent-based modeling, or NetLogo. You would use VenSim for system dynamics, and you would use Arena for discrete event modeling. And ne'er the twain shall meet. And those who were practicing within this area on particular types of modeling, because they couldn't speak with authority about the linkages, often they did so with prejudice, and cherished prejudices being foremost among them. And that time, thankfully, has changed. That old guard is still there. You will find it quite a lot. And I would say if you are seeking advice from individuals about modeling, try to seek advice from people who do have experience with multiple tools. And particularly if you're talking about hybrid modeling, you should talk with someone who's used multiple sorts of modeling. I would note here, for example, my colleague Ross Hammond has also engaged in some hybrid modeling. He's incorporated elements of Kevin Hall's model of metabolism, just like we have. Placed it in a context which can then be used with an agent-based model. He's someone I would speak highly of there. Peter Hoffman would be another person who's used multiple sorts of modeling and be very good. But the number of people like that is comparatively small. And as in small, I mean, fewer than a dozen people. And Jeff would be another one, a veritable graybeard of it. So I think within this context, we're seeing the emergence of a new system science that goes beyond one type of methodology, and there's good reasons for that. We can't afford to be so tribalistic that we ignore some of the very material benefits that come from tapping multiple techniques, either within the same model or within a given project to cross-check each other. So hybrid modeling will be a big feature of the coming landscape. We're seeing whole sessions of conferences like Winter Sim devoted to hybrid modeling, and increasingly this will be a key part of the landscape. Okay? So those are some comments on hybrid modeling. Any questions about that before I go on to the next topic? Yes?
Just a question, Nate, that's fascinating. So the question relates to a potential disadvantage of hybrid modeling.
Yes.
That you become master of none.
Right.
That it becomes so broad that your depth of insight is compromised, I guess. So the question is, how would you see a university, for example, or an organisation managing the use of hybrid models? Do you need a resident expert in each of 3 or 4 modelling techniques? How do you manage that, and how do you pay for the software? Right.
I think there's several pieces to your question. I'll try to do justice to each of them. So, are there disadvantages to hybrid modeling? In a certain sense, yes. I could imagine the prospects for doing the opportunity, the options of doing hybrid modeling could be a distraction. And maybe this is to what you allude, where you get someone doing it just for fun, right? They say, wow, I could weave these things together. And people weave them together without really thinking as deeply about the issues. It becomes more of a sort of technical game of sort of, tick boxes that can be checked. They've got a hybrid model, and I can publish it as a hybrid model, and it's less the substantive contribution that's emphasized. Could that be the case? Yes, it could be the case. So I could imagine that. There are certainly some practitioners from the methodology side, and I do both methodology work and application side work, and I can imagine someone saying, okay, we can be the first to plant a flag in this, using modeling in this way, and the first to plant it that way, and they're really not engaging with the substantive health challenges, and I would see that as a big missed opportunity. And that does occur. I guess a second, it's not common, but it can happen. A second sort of notable disadvantage could be, well, wait a minute, you got to walk before you can run, right? You want to have some confidence in any approach before you declare that we have confidence in all approaches. So if we're going to invest in dynamic modeling as a first step, do we really want to open the door to all 3 and, as you say, sort of become dilettantes in all 3 and masters of none, right? Could that happen for an organization just starting out? Yes, I could also imagine that happening. And in that sense, marshaling your resources and thinking firmly about your needs is very important. Being very clear about where exactly the hybrid modeling fits in. Is it needed? Is it really advised? So I think both of those are real shortcomings, and I'm grateful for you, Colin, for for articulating them. I will say, however, that it's been my experience that those are less common pathologies or difficulties than the very real one associated with that I see a lot, which is one method being used and force fit to conditions where another method would just solve the job so much more easily. And I have seen many projects. I have seen many dissertations or theses skewed and research results forestalled because banging your head against a certain approach is just not making progress. And if they were only open to weaving in some of another approach, it would be so much easier for them. So, in the scheme of things, I do think that those are shortcomings. I think that those are weaknesses or vulnerabilities, shall we say. But I also think that that if you look at the problems out there, they tend to be more, people trying to pound the square peg into the round hole. Now, you could argue that, well, wait. I mean, partly that's because there's very few practitioners of hybrid modeling right now, and as hybrid modeling comes out, we'll see more and more of these pathologies to people who are not applying it well and who are not really deeply knowledgeable. Just playing around with it or really not knowledgeably applying that. And I'll grant you that. I just see many cases where modeling techniques are misapplied or they're cutting the potential short because they're not using the right tool for certain portions of it. They spend all this time in an agent-based model to build up this representation of service flow. Spend months and months, maybe a year spending all this time where really you could do it in less than a month with the discrete event component of your model because it just captures it with much less risk of bugs, etc. So I do think those are risks. How would I advise institutionally someone setting out? I think there's a fair bit of what you say that has a lot of wisdom to it there, Colin. Look, if you have limited resources and you have limited time and you're just getting going, starting out in one methodology where you have good advice that you can secure will get you very far. And I would just say that knowing something about these other sorts of modeling and where they can fit in will be valuable to help maybe spot places in your exploration with this one technique where you might say, well, should we be thinking about a hybrid model now? Let's suppose you build an agent-based model. You have a focal population of interest that's comparatively small. Maybe it's obese individuals. Now, by comparatively, I know obese individuals are, a substantive fraction of the population, but it's not the entire fraction, and particularly for certain age groups, it's a smaller fraction. If you were to go there and, there's a real emphasis on interaction with stakeholder groups, and you find the model's just way too slow for that, you might think, is there a role for some sort of use of aggregate models for portions of this that would really speed this up? Or if you were needing to represent service processes with your agent-based model and you find it was getting bogged down in this, you should be aware that there's this thing called discrete event modeling, that it's not a solitude, it can be linked in, and maybe you should say, well, maybe we should think about that. This is not to say you need an advisor on each type of modeling. I would say you do very well if you have a really good advisor on one sort of modeling and you have problems amenable to that sort of modeling. But you should keep your eye on the context, and if you run into problems, if you run into real barriers that might be, alleviated, might be addressed or at least lessened by awareness of these other techniques, you should probably speak with someone who has some hybrid modeling experience. But I would agree with you that probably getting some experience with one technique that's reasonably deep up front as a conceptually clear application of system science will probably take you out of the danger zone where you're just flopping around, not able to apply system science at all, and just kind of, diffusing your energy through multiple types of modeling, where it would be much better to channel it into one sort up front, as long as it's a good match to your needs. Because I can't tell you the number of times where I've seen, a problem where the problem is of a certain sort. You get an expert in a type of system science modeling, but it's not the type you need, and so it just goes off the rails in this other way. So just make sure there's a pretty good match for whoever you've got. Jeff, do you want to say something on that? You have decades of experience in this.
I think it's really based on the personal history of the influential people. That's what drives it. It takes a long time to master one technique, particularly the problem conceptualization, the abstraction of the problem to that method. And that's a precious competence that takes a long time. And that, I think, is the kind of barrier. So you see the world a certain way because that's the tool you use.
Right.
The problem is that there are lots of other people using different tools who are doing much better at similar problems than you. So again, I like to think of it, the real challenge is how do we work together uncomfortably for 5 years? Because I think that's kind of what it takes. So how many people want to be uncomfortable for a few years?
Uncomfortable in the sense crossing the disciplinary divide.
Challenging your real prejudices and your skill set. Saying, well, actually, there is a better way. It's just that there's a little bit more to it than that. But some people are just exquisitely good at one tool set, and they will bend it so far out of shape to solve another problem. The real problem is that it is an unnatural, what did you call it? An abuse last week. It's abusive to use that method, or even make people think of the problem using that method. You can do it, but no one else will be convinced, really. So you can kind of fool yourself.
And once you leave, then après moi le deluge, right? Everything falls apart.
Yeah.
Annie, you were going to say something?
Yeah, so I don't know, how fit I'm to comment on this, but my personal experience, I think I was fortunate to start my modeling and simulation learning and career in a position that I was exposed to multiple kinds of modeling simulation and actually relative experts in each of the area. And I do see they are being very focused on their area, very expert in their area, and for different reasons. They invested that one area for like decades, and so they are very fluent in that. And in a way, it's hard for them to adapt to the other one. And for whatever reason, I was fortunate to expose to all of them at the same time, relatively at the same time, and having them mentor me in one area more in depth and able to accept them and then connect them all together. So I think that's valuable, and that makes it, yes, it is good to focus on one and invest your time to master that one area, but it's, I think, very important to be exposed to all of them so you have your own choice and your thought and your mind are open to the other instead of just stuck with one and very hard later on to accept another.
Yeah, I think getting, so I think, I'll echo Annie's comment again and Jeff's. I think, getting exposed to one, getting exposed to all first, that's good. You've seen glimpses of all. And then really diving into one that seems a good match to your needs based on the literature, based on what you're getting from people you're talking to, that seems a really good match. And really focusing on that for a certain amount of time, but just again, keeping an eye out for cases where it seems to be getting stuck. Because that's really the big pathology. People bang their head. You take a given tool and you, as Jeff said, a memorable phase, you bang it out of shape. You twist it. You twist it out of shape. So the exchange to which he was referring last year took place in my last boot camp. And someone was asking, essentially, couldn't we do this all in Excel? Now, in my youth, I happened to be one of the team members who was building Excel. So I was at Microsoft and on the Excel team for a portion of my career. And I have familiarity with Excel of considerable depth. But could you do this in Excel? You know, could you do everything here in Excel? So what I basically said is, there's a thing we call computation universality, and once you reach a certain point, you can do things in one, you can do things in the other, but it can be incredibly painful. It would be the equivalent, in my mind, it's in the same class of things as, dragging a train with your with a rope attached to your teeth, or going and walking on your knees 100 miles or something like that. I mean, you're just going to be so cut up by it. It's horrible. It's abusive. You're just going to be hurting yourself by doing it. And part of what I have seen, I think Jeff has seen it a fair bit, is cases where you have an expert modeler come in who's an expert in one technique, and then they apply it to another technique in the same brute force way, and it ends up being bent all out of shape and not really getting to the heart of the matter. It's unnatural. It's not being used to its proper use. It's not being put to the proper use. It's not a good fit to the problem. And that's what you want to watch out for. If you're running into barriers, and just be aware of these other techniques, and maybe at some point, 3 years down the road, 4 years down the road, you'll say, well, maybe now we have this person in our organization who knows about this other type of modeling. Maybe we should think about weaving that in. It's no longer an either or anymore. It's no longer you're either with us or against us. Yes, Dylan.
Yeah. So I can't say that I have as much experience in all the domains of modeling as the three of these here, but I can say from my own personal models that probably the best approach to this is not to, a shortcut to gaining expertise in this area is actually just to understand where each of them has its strengths. So when you encounter a situation, you can go, okay, this is something I've never done before. How am I going to represent this? Okay, this is, let's say, I'm by trade more an agent-based modeler rather than an SD person. But I know enough about SD, I know enough about discrete event, I know enough about pedestrian flows that I can say, all right, this particular piece that I want to build is best done with SD. What do I need to learn about SD for this particular situation? So in that sense, I don't necessarily need to be an expert in all of them. I can still specialize in the one that I'm good at, but I can recognize what expertise I might need when I'm going to need it, and that cuts down the amount of learning that I need to do to adapt to different situations. Again, this is just me and my personal exercises doing that, but I think that would be a fair thing to say. If you understand where a chainsaw is required over a screwdriver, you don't need to spend a year in advance learning how to use a chainsaw. You can just learn it before you need to use it, right?
Yeah, it's a good example. Right, but conversely, there are certainly times that I would most emphatically use the screwdriver rather than the chainsaw. Okay, so any other and there was a question about affording, and I think I'll try to hit that one this afternoon, where I'll talk about multiple types of modeling packages and cost trade-offs, as well as trade-offs associated with sort of the functionality, et cetera. I'll see if I can hit that this afternoon as part of my sort of wrapping up remarks. Okay. Any other questions before? I think we'll take a break, and then we'll return for a glimpse of another transformative trend within health sciences, which is the opportunity to bring together big data and this sort of modeling. Okay, so that will be after about 10 minutes. Is there food there, Jeff?
Not yet, but I guess it should be here.
Okay, maybe you could.
In the next few minutes, anyway. 3
Okay.
minutes, I think, scheduled time.
Yeah, it's coming at 10:30, I think. Any other questions before I break for that? Thank you for the questions and comments. This really enriches the session.